Bridge, we have a really exciting lunchtime guest for you. Kind of in a tradition where we've had other speakers from Austin who've come in and entertained our conference. I'm pleased to introduce a gentleman named Bill Alderson to you. He's a recognized cybersecurity and expert in networking packets and ransomware. He's been a good friend of ours. He's also in the incubator here at Concordia University, his firm called HOPZERO. So Bill is going to tell you more about what he does and some interesting insights into security. So have your questions ready for Bill. As you've been doing before, just write them up on your Zoom dashboard, and we'll listen to Bill's presentation for a few minutes and then entertain some exciting Q&A from the crowd. Thanks.
Well, I am Bill Alderson. I can state that as a truth. And in our world today, there isn't a lot of truth that we can prove definitively. No ifs, and, wells, or buts, right? It's very difficult. Deep fake. I have some new software that I can record my voice into, and then I can type something out, and it will say whatever I said with my voice. So there's a lot of fakeness. One of the things that I like to talk about are packets. Packets cannot lie. When a machine sends a packet on the wire, it's on the wire, and if you listen to it on the wire, it's not a lie. Now, what can be a lie? When a ransomware device or command and control gets a hold of one of your most vital servers or your workstation, what happens is they take command and control. They're communicating from afar and controlling your computer, right? Well, here's the thing. They can expunge their behavior from going to something like Splunk or Elasticsearch. So they can avoid detection because those applications that are sending that information in the form of a log to a syslog or to a Splunk server, and the guy who's in your machine can expunge his behavior from entering the log. So consequently, we're not always safe. But if we're looking at things on the wire never lies. If a packet hits the wire for command and control, it hit the wire for command and control. And if it goes to Russia, China, North Korea, or somewhere like that, it definitively went to Russia or China or somewhere like that. So we're not depending upon an application that can be controlled. If the hacker sends a packet on the wire, it's the truth, and you can actually see it. So I've been analyzing packets since 1980. I recognize that that might be a little bit before some of your time. You know, the secret to aging well is losing all your hair and shaving it off, because then everyone thinks that you're young. So not true. 40 years, since 1980, I've been looking at packets on the wire. I was a communications engineer starting at Lockheed in 1978. And I ended up having to look at packets on the wire starting in 1980 with a data scope that was a scope that would listen to wide area network stuff and look at packets and data going across the wire. And the name of that data scope happened to be Halcyon. Now, what else is named Halcyon? The sleeping pill. So connected to packet analysis, and the first name of the first analyzer was Halcyon. And it's akin, because network protocols and that sort of thing can be pretty dry. If you've ever read an Internet Engineering Task Force RFC, request for comment, they can get pretty dry. And they aren't so that you can really understand it. They're to set the specification that you have to work to. But it doesn't tell you necessarily how to do it. So TCP/IP, DNS, all these protocols that we have today started out in a lab and then got set as an RFC. Do you know that the RFC, request for comment, is simply people in academia sending out and saying, hey, I think this is the best way to do it. Request your comments. And most of the internet standards that we have today are still in what we call RFC, request for your comments. But they became a de facto standard based upon whoever had the best information. The best information algorithm, do we use that today? Not really. It's usually who has the most money. So whose protocols are promulgated mostly? Well, it's the big companies, right? And they start out like Cisco and that sort of thing, and they have a protocol. Well, Microsoft tried to control protocols. And they did this until the Department of Justice got a hold of them and said, you know, you're the de facto standard and no one else can communicate with your servers, your Exchange servers, your file servers, your SQL servers. So we are going to make a judgment against you that you are a monopoly. And you know how they controlled that monopoly? A good friend of mine, Dr. Harry Saul, was the hammer for the Justice Department. And you know how Harry controlled Microsoft is they forced Microsoft to publish their protocols. So when Microsoft created something, they would then be forced to expose their protocols and specifications that Oracle and all the other big companies could get a hold of, and then learn how to emulate or cooperate or interoperate with Microsoft. Now, IBM protocols preceded that, SNA and that sort of thing. I'm probably one of the world's foremost network analyzer folks with Token Ring. Token Ring, of course, was promulgated by IBM. I went down to Raleigh, RTP, and taught literally hundreds of IBM Token Ring engineers at IBM how to practically use and troubleshoot Token Ring, okay? So I tell people, Ethernet is for realists because we have collisions on the wire. Token Ring is for idealists, okay? So you got idealists and you've got realists. So realists are Ethernet because we had collisions that theoretically wouldn't work. But in practice, it actually worked quite well until we went and we learned on the Ethernet side to star wire Ethernet hubs, which means there's only one Ethernet per user. Therefore, then we switched everything so there's no more collisions in Ethernet. So we stole the wiring technology from Broken Ring, Token Ring. We applied it to Ethernet, and the rest is history. Now we have 400 megabit Ethernet. So also, I want to talk a little bit about packets and protocols and their importance. You may not realize this. How many of you have ever heard of Novell? The big red N, right? Ray Norda, they built $1 billion business of these big red servers. And then everybody connected their PCs to these things, and they created these huge enterprises. Well, Microsoft wanted a piece of that pie. So what they did was they chided Novell that they were not, their protocol called Novell NetWare IPX was not a standard. So they kept chiding Novell, hey, your system is not a standard, until Novell finally said, okay, we will give our IPX protocol over to the IETF, Internet Engineering Task Force, to become a standard. They did that, and Microsoft, Bill Gates, Ballmer, all those guys had a huge party. Because as soon as NetWare published their protocol as a standard, Microsoft was free to emulate it and interoperate with it without paying any fees. How many of you saw Novell NetWare being the preeminent worldwide network server? And a year later, after they published that standard, Microsoft on a weekend would convert huge Novell NetWare server environments and workstation environments over to Microsoft. Why? Protocols. So if you don't know it now, protocols run the world. When the DOJ wanted to enforce the lawsuit against Microsoft, what did they do? They controlled their protocols. They forced them to publish them. That way, everyone can interoperate with those systems. So, do you see how important protocols are to the market? So, wherever you are and whatever you're doing, there's more that meets the eye under the covers. So, Cisco has a lot of the major protocols. Every time they come out with a proprietary capability, after they perfect it, and then they draw away all the people from other vendors into a proprietary format, which we call lock-in. Now they've got the customers locked in to the Cisco framework. You have to buy Cisco routers and switches, or you can't use the redundant framework, high availability framework. And then Cisco, after they establish that proprietary capability that no one can emulate, they then go out and say, hey, IETF, we're going to give this to the standards, and then it becomes a standard, purportedly so other vendors can participate. So these are examples of why packets are important, why you need to understand it, and why these protocols are important. We have a huge protocol change that's underway right now. Anybody not know TCP/IP? Do you know it's a 50-year-old protocol? TCP is a 50-year-old protocol, and it's being replaced right now under, just very quietly. You know that Google and Facebook and are already fully using a brand new protocol called QUIC, Q-U-I-C. The QUIC protocol is on all of their servers, and now it's on all of the browsers. So when you communicate with a Google system or a Facebook system off of your phone, off of your machine, it's no longer using TCP. It's using UDP with quick transport on top. It's up to 10 to 100 times faster. And when you drive down the road and your phone switches from cell A to cell B to cell C, it's got an automatic algorithm that switches those. You have 10 connections to your app, changes all those 10 connections with one link. It's rapid movement. 5G. 5G, you cannot use. You heard it from me. You cannot use 5G in the bandwidth that it allows unless you're using a protocol like QUIC, Q-U-I-C. I have a website called gotquick.com. And I go through and I talk about all of the various things about this QUIC protocol. So protocols are very important. Microsoft is starting to use QUIC protocol for all your server traffic, for your file traffic. This is all happening. People don't even know it. How many of you have heard about the QUIC protocol? A few of you, yeah. It's a huge change. So I talk about this because packets and packet analysis is the fundamental of all network security. If you don't know packets, it's impossible to be a cybersecurity expert. Now, you can be an ID expert, an IAM expert, but you can't truly be a cybersecurity expert if you don't know packets on the wire, if you don't know how to load packets. So packets can be loaded with a free analyzer on every Linux system called TCP dump. It can also be on every other machine in the world. You can use Wireshark. How many of you have heard Wireshark? How many of you have ever done a Wireshark? There you go. So you can capture. Wireshark does a fabulous job of decoding. Why do I know these things? Well, I was at the first network analyzer vendor called Network General back in 1986. I actually had hair back then. Not a lot of it, but I had some. So I've been working with packets, teaching people about packets, doing big conferences under NetWorld Interop. If you guys remember Interop and NetWorld, I was the guy who did Network Forensics Day and trained everybody in how packets worked, created a certification program that trained 3,500 certified network security experts. So that's where I come from, and that's a little bit of my history down there. Been with several different companies, Network General, we IPO'd, Pine Mountain Group or PMG Net Analyst. We got acquired by a local company here called NetQos. How many of you have heard of NetQos? Not very many. Well, then later on, a few years later, we got acquired by CA. Now, how many of you have ever heard of CA? There you go. Now I know. Now I'm hitting it. So I was a principal services architect at NetQos/CA after they bought us. Now, you won't see very much of NetQos products because they're not really that, they're named differently and they've been assimilated and they're all over the place. So one of the things that people like to talk to me about usually, and it's kind of interesting, is Mike Lindell, the My Pillow guy. Anybody not heard of Mike the Pillow guy? Yeah, you've not heard of him. Okay. Well, he sells My Pillow, and you can buy these pillows, and he's on all the different news stations and that sort of thing, and he advertises My Pillow. You can buy Giza sheets, you can buy pillowcases, you can buy all sorts of stuff. Well, he got totally involved in politics. And so consequently, he thought that there was a lot of fraud in the last election. So he had this cyber symposium, and he announced to the world that he had all the packets from the election that proved election fraud. And me having the code name of Packet Man 007, you don't think that I was interested after 40 years of looking at packets that this guy said he had all the packets proving fraud for the 2020 election? So was I not all over that? Not to mention, he offered a $5 million, right, challenge, a prize for any expert, cyber expert, who could prove that he did not have proof of election fraud. Now, true story, I'm a conservative. I went thinking, hey, maybe he's got proof. But it was very obvious very quickly. He did not have even the PCAPs. This guy really believed his own stuff, if you know what I mean. I met him, spent about an hour with him. Very interesting character. I think he believes it, but I'm not so certain. Anyway, so I proved, and I was at this cyber symposium, and there was media there on the left, there was media there on the right, there was media there from the north, the south, the east, and the west. And I got interviewed by all of them. And I had to basically break the news to everybody that, yeah, there is no proof, there is no PCAPs. And so I have a whole presentation on exactly how I proved that Mike Lindell didn't have it. And I submitted for the $5 million award. Gave him a 10-page report with all the details and that sort of thing. Sent it in as I was supposed to, certified mail. What have I heard back since August? Crickets. I haven't heard one word. But Mike Lindell was talking with Steve Bannon one day, and the topic of Bill Alderson, the cyber expert who proved that you didn't have the goods, came up, and he pretty much dismissed. After that happened, more articles got written, and all the people that I've worked for and pulled the baby out of the lion's mouth doing packet analysis jumped on and said, not a good thing to throw Bill under the bus about his ability to look at packets. So anyway, there's hundreds of articles. If you go Google Alderson and Lindell, the saga continues. And so anyway, a lot of people like to just hear about that because my friends and relatives said, Bill, you're in the news. So anyway, it was kind of fun. But my topic today is the SolarWinds breach. What can we learn from the SolarWinds breach? First of all, there's a security analysis hierarchy. A zero-day attack is something that no one has ever seen, right? 911 was kind of a zero-day attack, right? But a few years earlier, we did have something in '97 where they tried to blow up the World Trade Center. So it wasn't completely a zero-day. They knew they were trying. But using that method of aircraft and getting on board an aircraft to do this, you know, with knives and that sort of thing to perpetrate this, that was a zero-day. So what does the government do with a zero-day? Well, after that, we created Homeland Security, we created the TSA, and now you get on an airplane and grandma gets strip searched to make sure she doesn't have the same tool that these perpetrators did, right? So that is an example of how security works today. If you haven't seen it, we can't solve it. And that is almost the truth. We cannot stop zero-day attacks. So whether it's like Facebook a few weeks ago, who went dark for a few hours, whatever the case may be, the oil pipelines, hospitals, etc., they're getting hit with these security attacks. So what we really need to be able to do is address the zero-day, right? We address the zero-day, boom. And then we don't want to be like the government, right? Because they only can fix and mitigate problems that they have seen occur before. It's monkey see and monkey do. So when you look for security solutions, go look and weed out all the monkey see, monkey do people. Why? Because anyone can stop something that they know can happen. The trick is knowing how to address and diagnose specialties. So the fundamentals of all security, the basic fundamentals are packets, who, what, when, where, and why. I call them the 5 W's. So I'm going to talk a little bit about that. The SolarWinds breach, if they would have attended to the basic fundamentals of the 5 W's, 18,000 government and large institutions would not have gotten compromised by the SolarWinds attack. But what do we have out there? We have a lot of marketing, billions, a lot of arm waving, big government institutions, NSA, FBI, CIA, all those guys, and they're out there talking like they are experts. And did you know that the NSA, the CIA, and the FBI in the last 3 years have all lost their most valuable tools, the red team tools, what they use for lawful intercept. So the very people that we give billions of dollars to keep our information safe lost the very tools that they use for lawful intercept. Now, what does that mean? That means that all those script kiddies who were not very smart, not very capable around the world, all of a sudden, with those 3 big 3-letter companies, got all these tools and all these capabilities just like that. And people started compiling them in different ways. But the problem is there's very simple ways of addressing many of these things by looking at the 5 W's, the who, what, when, where, why. So here I have prepared for you a 11 evading steps diagram of how the attack occurred. So let's take a look here. I think I can do this. Well, you can't really see that very well, but you've got the criminal and he's got this bug. He created a DLL, and then that DLL got inserted into the coder's files. The coder then compiled it, creating a signed compiled version, which then went out and got put on the internet for updates to all those customers. The customers, because today, it's not about purity and really being able to do some of these things. It's about how easy it is. So what do? Everything is automatic update. So an automatic update goes out to the internet server, pulls that information down, and puts that right into the middle of your SolarWinds monitoring system. Now, what does SolarWinds do? SolarWinds is a monitor. It goes out and interrogates your SQL server. It interrogates your firewalls. It interrogates your routers and switches. It interrogates your workstations. And because it interrogates very deeply into the bowels of all these systems, it has to have what in order to be able to do that? It has to have all of the credentials. So armed with the credentials inside the SolarWinds system, the SolarWinds did not itself contain any data. It just contained all the access credentials to absolutely every single system in the network. Armed with that, what do you think those guys could do with it? A lot. And that's what happened. I'm going to tell you a few secrets a little while later that you're going to really shake your head at, because it's kind of comical, actually. So we got this 1, 2, and 3. And then what happens after 3? Well, then he auto installs it, and then it waited for a while to see if it was in a sandbox. And you know, the very first test that they did was, do I have internet access? Do I have internet access? Does this compromised capability have internet access? And when it said, yes, you have internet access, it can continue. Because after the bug comes in here, it compiles all of those credentials. And knowing that it has internet access, it exfiltrates out to this Microsoft server. Microsoft server used a certain DNS name. But the start of authority for that DNS was sunburst.sinkhole.blah, blah, blah. Really? Had they been watching where they were getting their DNS resolution on the start of authority for this server that was out here in Microsoft, it was 20.0.140.1. Microsoft Azure server taken over by the criminals, or maybe even purchased by the criminals, and all of those credentials were gathered up and exfiltrated over there. And then the next step was the criminals now were told, hey, you got all credentials from company 1, company 2, company 3, company 4. After they have all that capability, the next thing that they do is they then enter in and start doing what they do. So they can encrypt. They can also add landmines. Now, if you read my report, that we're giving you all a copy of this report. If you read that report, it's not too difficult to understand that when these guys come in and this hacker now has full command and control over your entire enterprise, one of the things he's going to do is he's going to leave a landmine, because this isn't a once and done economy. This criminal economy that we call ransomware, phish, etc., is not a once and done. No, after they get your Bitcoin, from problem one in 2020, they set themselves up so that another hacker or themselves later can put landmines. Now they can log in, put landmines anywhere in your environment. And what are we finding out about SolarWinds? It's the gift that keeps on giving. Why? Because they put landmines in there waiting to come alive, because next year they're going to need a new revenue stream. It's the gift that keeps on giving. And it's all because they allowed this system to have internet access. I'm going to show you a little bit more about that. So these are the 11 evading steps that occurred. Direct internet access. When I was at Lockheed, do you know that we put a power conditioner on every IBM Selectric typewriter? Power conditioner. So that when you type on the IBM Selectric, SECRET, that the Russians who are tapping the power lines down the street somewhere cannot see from the impulses that are sent back through the power line what was typed on the IBM Selectric. And at Lockheed, we put all these systems into place, and man, we put power conditioners and everything on all sorts of stuff. We did isolation with from electrical over to optic, right? Telephones, optic. Why? Because they can't tap the optic easily and they can't get it. So at Lockheed and in the security environment, man, we isolate. We isolate those servers so that they cannot talk to at least the internet. And some of our networks are highly classified, and we cannot even connect them to the internet, purportedly. Okay? So air gapping is a concept that got lost. And now we churn out all of these certified people from all these big companies through their marketing department. And the whole sales factor of marketing is to say, my product is really easy. You can turn it on and update all of your stuff by just allowing your client and your server to go to the internet to update things. I don't believe in it. It's how the fox gets into the hen house. So I'm very vigilant about air gapping you guys. Middleware, databases, backup systems, key management systems. Those need to be air gapped. You don't want them going to the internet to update. And as a matter of fact, did you know that every Microsoft installation, you can click a few buttons, and instead of every one of your workstations going directly to the internet to go to Microsoft to update, it updates on an internal server. And you know what? That server from Microsoft is free. How many people are doing that? Not very many. What are they doing? They're allowing all their servers and workstations to go directly to. I've worked for billion-dollar companies before, and I very quietly explain what's happening, and I see this incredible Microsoft SQL server that's going to the internet. So I pull aside the manager and I say, hey, you know, you're allowing this SQL server to go to the internet. Oh yeah, well we do that because we want it to be updated. So the key to that, the fix to that, is to use these Microsoft tools that are free and turn on a Microsoft update server inside your institution and turn off internet access for all those vital servers. So they have to go inside. They still get the same updates, but they get it from a server that's hardened and inside the institution instead of allowing every device to go out, because it's easy. Because our work in security and performance and systems is not to make things easy as it is So job one, make sure it's secure. Now, SolarWinds sold all these people a system that would update its premises and watch the premises. All the firewalls, the routers, the switches, the network infrastructure, that's what SolarWinds did. So how do I know some of this stuff? In the mid-90s, in San Jose, California, all the founders of SolarWinds, the technical founders of SolarWinds, came and flew to San Jose, California to have me teach them packet analysis using the sniffer. So I think I kind of know what's happening. Now, since then, and I use the term loosely, and some of you might be a little offended, but get over it. I'll offend everybody by the end of the day. But you know how Elon Musk thinks about MBAs? What did he say about MBAs? He says they're ruining corporations because they manage with only one element, the financial element. So all the guys at SolarWinds who were the technical founders left and were replaced with Elon Musk's MBAs. So now they make all the decisions, and when it comes to security and these other sorts of things, they're probably not totally on their game when it comes to making certain that your systems are secure, because their focus is on how much revenue we're going to have next quarter and how efficient our programmers are and that sort of thing, right? Wrong focus. You have to do. So SolarWinds sells a premises capability, and then they come along and the sales guy says, hey, we can add internet monitoring to your SolarWinds platform with a 20% increase. You don't have to buy a whole nother system. And they say, okay, great. So now the SolarWinds Orion monitors not only the premises, but also the internet. And then they come along and they say, hey, we have a new cloud module. And for another 20%, you can also monitor all your cloud resources. So now your SolarWinds Orion system monitors every device on the premises, every device you have on the internet, and every device you have in the cloud. What do you think happens when that thing gets compromised? What happens when it gets compromised? You just lost all your credentials for everything on the premises, everything in the internet, and everything in the cloud. Because they have everything in one egg cart. Okay, so the better way of doing it is to have a separate system for premises from SolarWinds, a separate one for internet, and a separate one for cloud, so that you are dispersing your risk, right? Or like most people do, they have a different vendor for premises, a different vendor for internet, and a different vendor for cloud. So then they are dispersed. You see how that works? They're a separate system. If one of them gets compromised, you didn't compromise absolutely 100% of everything. And most people, because you've got those Elon Musk MBAs, right? They're going to put everything in one platform because it's easier, okay? So this basically should tell us that there's more that meets the eye than simply buying stuff. Okay, the 4 communication perspectives of a vital server. So a server communicates, the highest priority is what's coming in through your firewall and hitting your server. This is your vital server. It's got information on it. If it gets compromised, it's catastrophic. Your entire corporation can go down. So those packets that go into the firewall get mapped over to an internal address. Those are incoming packets from the internet. That's one perspective, the incoming. Then you have everything going out. So that's your workstations going out, your servers going out, and then you have stuff going on the inside. What happens when one of those machines gets compromised by ransomware? Internally, you get compromised by coming in, you compromise a machine, and then the machine goes out and fans out and talks to all the systems on the inside and starts infecting every one of those systems and synchronously just ransomwaring and encrypting all those devices. So number one perspective is incoming. You have to be very vigilant on incoming. Outgoing. Well, what's outgoing? You got an email. You click on the email and you just invited whatever server is out there to install software on your machine. A few weeks ago, Apple got caught, right? Right before 15.0 came out. Apple got caught. There was a Pegasus, zero-click compromise. What does zero-click mean? It means you didn't even have to click on anything. If they sent you an email or through Messenger or what have you, and it went to your phone, it automatically compromises your whole doggone phone. Boom. So that's what a zero-click is. It's a zero-day attack that you did not have to participate in. But as soon as that thing comes in, now it goes out, right? So you have to watch things coming in, number one. You have to watch things going out, number two. And you have to watch things on the inside of your institution. If your middleware server never communicated with 200 devices, and all of a sudden it starts communicating with 200 brand new devices, ding, 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 something's wrong, right? You have all these new sessions. Well, it's probably internal going on. So these are the four perspectives: incoming, outgoing, external, and internal, right? I'm going to show you pictures. So on the left, you see a picture of all these internet devices with the actual mapped location on the internet, with the incoming server on the right that they're going to. Yeah. I take a PCAP, I load it in, I can show you who your most vital servers are communicating to and where they are communicating to. Not only that, I can show you whether that server is on the cloud in Oregon or in the cloud in Ohio. Boom. The picture on the right is your internal devices, your RFC 1918 addresses, your 192.168, your 172.16, and your 10 dot networks. And you can see where traffic is coming from on the internet, GeoIP, and you can see where it's going to inside, which data centers are going to. And then you can click on those machines and see more. Here's the internal devices. So these are your internal systems going out. Here's some guys talking to Japan. What if you saw North Korea or Russia or China on there? I do. And it's scary. How many of you know where your most vital server is going right this minute? Well, one of the problems is it has what we call a packet lifetime, which is time to live or hop. And that packet lifetime is pretty much infinity. In order to go on the internet from that cage up there to any other cage in any other location in the world, it takes 40 packet lifetimes. 40 routers. So if you're in London, it's 40 routers to Australia. If you're in China, it's 40 routers to the US at max. Did you know that the packet lifetime in every one of your Linux servers is 64 by default? Your Microsoft systems are 128. Your Apple systems are 128. Your Cisco systems are 255. And your Oracle systems are 255. They can go around the world 6 times before running out of packet lifetime. Okay, I'll share with you how we control packet lifetime to control the attack surface of devices. Okay, So here you have internal traffic going to internal traffic. What if you had a map like this right now showing who's communicating and who's trying to send things back and forth? Or public facing the internet. How many of you handed out something like VPN credentials after we experienced this situation last year? Like candy. Who's connecting to your VPNs right now? Where are they located? If they're in the US and in the location, then you can know that they're coming from and connecting to the appropriate points. If they're not connecting to the appropriate points, because all of your VPN users are in China or Russia or South America, and they shouldn't be, that's a pretty big indication that what? Something's happening that shouldn't be happening. So these forward communications perspectives, it starts out with what we call a public address and a private address. So you want to vet anything red coming to anything green. What's an internal address you use on your middleware? Usually 10 nets, right? 10 dot somethings. If a 10 dot is talking to something that's red, which is an internet address, ding, 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 right? It's a problem. So you want to know what's going on there. So the 5 W's of security analysis are knowing who, what, when, where, so that you can answer, why am I allowing my most vital server to communicate to these devices like SolarWinds did? Aren't those plausible questions? So why don't we take a little bit of a moment? I'm not sure I'm getting the signal here. Maybe we want to make it a little more interactive. Maybe you can ask me some questions and I can go to some questions and that sort of thing before I finish up. Mark?
So Bill has a book on breach, and everyone who attends the conference will get a PDF of this document and physical copy. So it's a really in-depth decomposition, I guess, of the SolarWinds breach.
Not one question? Help a guy out.
In the small shops, people are networking. And there are people in this room that have to run their networks inside, as well as, provisioning laptops, and code, and
right.
Run their business on legacy.
Yes, sir.
Roger Hammer. You talked about a number of topics. In case of the shop, what were the first 3 things you look for?
First 3 things. What I do is I simply take a PCAP, a TCP dump off of any firewall or any server that I'm fearful of might be getting out. If I'm responsible for that server, I'm going to take a TCP dump off of it. I'm going to load it in and put it into a tool that will show me where data is traveling visually. So it doesn't take a rocket scientist. It doesn't take a guy who's been doing this for 40 years to be able to load this in and see. And you can see right there that I've got a picture on a map of where, and that was actually this right here. That's SolarWinds Breach. Because I analyzed the actual packets of command and control going to that Microsoft server, and the things that I learned in there, incredibly powerful. So it's usable by the average person because you can see that this server is communicating to Brazil, Russia, China, etc. And then you ask yourself the question, do I want that vital database to communicate to Russia or China? It's that simple, yeah. Yes, this was actually communicating from Austin, Texas in my lab over to the data center in Azure in Virginia. you wouldn't know that it was foreign. However, if you go into my detailed information here, you'll see that that DNS server was resolved from sunburst.sinkhole. I am a hacker hacking you, giving you this IP to connect to. And those are very simple to see and understand. Why am I communicating? So the who, what, when, where, and then the answers the question why. Why am I allowing my middleware box that has the most vital HIPAA information or company compromisable information in the world to communicate to Russia? And the answer is very simple. It shouldn't. Where should all your VPNs be connecting to? Should they be connected? If you're a hospital in Atlanta, they should probably be in the Atlanta area. If you start seeing all your VPNs connecting from Brazil and Russia and China, what does that say? I mean, it doesn't take a rocket scientist. It doesn't take a protocol analyst with 40 years experience to see that, yeah, my VPN should not be connecting to clients in another country. So those are just, when you say the first couple of things, it takes 15 minutes to take a TCP dump off of a firewall or off of a server. And then what we do is we tell you to strip off all the data. So you're not giving us the data, we're just giving the headers, load it in, build a map, and show you where it's communicating. That's the first thing I do when I do security analysis. I say, hey, give me a TCP dump because I am packet man, right? And when I went to that conference, that cyber conference, I loaded in some trace files from some of the elections. And I could see this election network was communicating, it wasn't communicating to Russia and China, but it was going to Europe and other locations. So those are just immediate, simple tip-offs. My God, where is my data traveling? And then I use this concept of packet lifetime, and that's what we do at HOPZERO. Instead of allowing your Oracle database to communicate to Russia or China because it has a packet lifetime of 255, we neuter that packet lifetime back down. What do we neuter it to? How many hops, how many router hops do you have inside company A? 10? 10 router hops? So we neuter your Oracle database so it can only communicate through 10 routers. At the 10th router, that packet is summarily discarded. Because when the hop goes to 0, or the packet lifetime goes to 0, and every time you go through a router, so you start out at 255, go through one router, 254, 253, 252, 251. It keeps going like that. Now, if you turned off hop in the internet, people say, well, Bill, what if we turn off hop? What if somebody gets in and turns it off? Well, the entire internet will go down. Because if you send a packet out into the internet, this is why Vint Cerf, who's the father of the internet, who did all the TCP programming, when you put a packet into the internet, and if it gets lost, it will spin around forever until something kills that packet. If nothing will kill that packet, like hop starvation, where the hop goes to 0, every time it goes through a router again, it goes 255, 254, 10, 9, 8, 7, 6, 0. Boom, that packet is expunged from the internet. If that doesn't work, the entire internet and your entire network stops working, because it will spin those packets, consuming 100% of the bandwidth between those routers forever. Hop has to work. So by limiting how far your vital server can travel, it can't communicate with anyone more than 10 hops away. It can't communicate to someone more than 10 hops away. So even if you had a bad internal person, your DBA was a bad guy, and he wanted to exfiltrate like they did over at Anthem, they exfiltrated the entire Oracle database. Why? because it could go there. There was no restriction. So when we first started the internet, we wanted everything to go everywhere, right? It was an academic system. But now we put our most valuable vital data on the system, and then it still has this huge hop count. It still has this huge packet lifetime. So by lowering that packet lifetime, that system can no longer communicate outside the data center or no longer communicate outside your company. So it's safer, right? Because you've reduced that. Yes.
Bill, it's really been entertaining. And how about I see you from
Thank you.